Hello, this is the introduction of the AlephPhysics plugin. And if you open the game, you will see this interface. This is a framework for you to test the simulation. In the scene, we can see there are some birds. These are game objects. And since our simulation is done on GPU, so this are used to show that the interaction between the GPU particles and the game object. So if we click right button, we will spawn the particles. And we can see that the particle can interact with the boundary. And we can change some properties such as the velocity. If we change the velocity to a positive value, it will move to the right side. And on the other hand, it will move left. And we can also change the gravity. So if we change it to a positive value, we can see the particles moves up. And now the bounce is no energy loss, so the sphere will keep moving. And we can stop the simulation by clicking this button. And all the particles will disappear, and we can play again. So let's change the gravity back to a negative value. And we can see that here there is a record hit. If we click it, we can see that once the particle collides with the boundary, will trigger audio. So this is interaction between GPU and CPU. A GPU will send the message to CPU, and then in the C# script will play an audio. And we can also create open the BVH. This is to show the bounding value tree, and we will create a bounding value tree on GPU, and we can also show this tree in time. We can see that in each frame the tree will be recreated, and it looks very fun. And if you don't want it, you can close it. The painting of the tree is also on GPU. So basically, nearly all of the calculations are done on GPU. And we can also change the size of the particles to make it a little bigger. This may have a little effects on the performance. We can also change it to small particles. Like here there is a lifetime. This is to change the lifetime of the particle. So we can change it to a big value, and we can also change it to a small value. And if we spawn a new particles, and it will disappear, since lifetime is 1 second. Okay. And we can also open auto spawn. Auto spawn, which means that will auto spawn particles. Let's have a try. Click auto spawn. You can see that will auto spawn the particles, right? And if only BVH, you can see it's quite interesting. But if you spawn too many particles, this may have a effect on the performance. Now it can support I think 10,000 particles, but normally 1024 will be a good choice. And we change the lifetime to a very huge value, and you can see the particle count keeps increasing. I will stop the auto spawn and close the BVH. So by this you can create some interesting effects. You can see that when we click the right mouse, will spawn particles. So this means that we can trigger the creation of the particle on the CPU side and do the simulation on the GPU side. Now I will clear all the memory and try again. So this time I will spawn one particles. Let's change the velocity to 0. And we can see that when the particle interacts with the bird will change color. So since these birds are they are just normal game objects on the CPU side, so this is implemented by the ASYNC readback from GPU to CPU. So by this function, you can make an interactive between the game object and the particles. And on the other hand, you can also place send your game objects bounding direct to GPU and do the simulation. Now let's stop and try another feature. And we can see that here like collider type, and we can change it to box. And you can see that we can stimulate AABB box, and they also can collide with each other. But now the box can't interact with the bundle because this is you can see that this white border, this is actually a SDF texture. It's a signed distance field texture, and normally only the Sapphire type can support SDF texture. So next, I will introduce you how to create a SDF texture for you to interact with the environment. Thank you. Hello, in this video, I will show you how to create a 2D SDF texture. In the scene wheel, we can see there are two systems, System 2D and 3D. One is for 2D simulation and the other one is for 3D. They have similar features, so I will only show how to make texture in 2D. And now the SDF texture only supports 2D. We can see there is a SDF generator object in the scene, and it has a time map attached to it. So we can create the time map. And literally this time map will be used to create a SDF texture. You can create anything you want, and after you create it, then you go back to the inspect window of SDF generator, and here you can set the texture name and the path, and then you can click the generate ground collider SDF, and it will generate a new SDF texture. And you go back to the physics theme game object, and here it has a SDF texture slots, and put your new created texture here, and it will use this texture to make the collision. So let's have a try. Click play button. As you just right-click the mouse to make some particles, and you can see that the particles can interact with the new created textures. And by this function, you can implement some very interesting functions. For example, your environments are made by some grounds. Maybe your environments are not made by time maps, but you can also make a time map as a background and make it hidden. Then you can use this function to interact with the particles, and it looks like just like the particles interact with your grounds. So in this video, we have shown how to create SDF texture. And in the next video, I will show a 3D version. Thanks. In this video, I will show you how to use the 3D version of the simulation. We have two objects, and if you want to use 3D, just activate the 3D version and deactivate the 2D version, because they use different cameras. So we need to make sure that the other one is closed. since we have the setting render pipeline we are using is a 2D version, we need to change it to a 3D version. So go to the assets and settings. You can see there I have created a 2D render and a 3D render. If you don't have a 3D render, you need to right click and create rendering and go to this one, URP asset with universal render. This is the 3D version. Since I have created, I will simply click it, and you can see that, click the 3D data, and you can see here there is a add render feature, and just make sure the 3D Sphere 3D feature is added here. And after that, you have one thing to make sure. Go to the assets, edit and project settings, and go to quality. Here is your render pipeline, and we need to make sure that we are use the 3D version. Okay, change it to 3D version if not, and continue. And now we are changed to 3D version, so also change here to 3D. And you can focus on the simulation 3D. And I have created a boundary. Okay, this has a phase cooling, so you can see the particles easily. And after that, you can configure some parameters in the inspector, but we will just run the simulation. Click play button. And make it bigger. So you can, this is a 3D version of the physical simulation. The interfaces are very similar since they have similar functions. And since it's 3D, so it's hard for me to spawn the particles by the mouse click. So we can click this button to spawn the particles. And you can also change the velocity. Okay, change the velocity. Let's change the velocity z. So the velocity may be 2. And you can manually spawn. You can close the BH. It's the same as the 2D version, so I won't introduce more about them. And it also supports server version, and maybe this version, current version only supports the server version. And you can, there is a one function I forget to introduce in the 2D version, is that you can pause the simulation. And you can go on to play, and you can click the frame button to go step by step. Okay, this is very useful once you are debugging or do some testing. And there are also lifetime gravity. All of them are the same as the 2D version. And since I haven't, you can't change the camera view in this window, but you can change it in the scene window. Okay, and you can also spawn the particles in the inspect window. Clicks play and manual spawn. Okay, this may looks much more clear. Like you can also stop the simulation. You can also change the spawn position. Change the spawn position and spawn the particles, right? And you can also set parameters. There are more parameters in the inspect window than in the gameplay UI. So you can take a look of these parameters. Most of them are very straightforward. And here you can see there is a maximum object. This must be predefined before the simulation. And this is used to decide the max number of the particles in the simulation, and it can't be changed during the simulation. And if you spawn more particles than the maximum number, it will just not really spawn them. And I think that's it. In the SFT texture, currently the 3D version doesn't support SDF texture. This is because that I haven't figured out a way to create a 3D SDF textures. But technically, it is fine to do it. And here we can choose the boundary mode. There are two versions. We will use the plane check. Basically, they will use this plane as a boundary check. And you can see that we have set a cube collider. You can see that it's exactly the same as a boundary. And the 3D version are basically the same as the 2D version. They have nearly the same functions, so I won't introduce more. And I hope you can enjoy this plugin. There are some documents in the plugin. It's about the implementation and about the algorithms. There are many interesting algorithms used in this simulation. So you can, if you buy this plugin, you will have all the source code and the shaders, scripts, and the links to the algorithms. And I think you can make your own, add more functions to extend it, and to this plugin is also very easily to integrate into your game. So as I have shown that we can change the spawn points, right? So that means you can attach this spawn point to your game object. And we have shown that we can, by clicking a button, we can create a spawn particle. So that means you can add the event to your game script to trigger the spawn of the particles. And another thing is that the particles can interact with your game object. You will see that here in the gameplay, there is the actor's parent. This is the game object in the scene, and this game object will interact with the particles. So you can add some predefined game object here, and once as soon as your game object has a ABB collider box, and then if the particles interact with your game object, it will trigger an event, and this event will be sent back to CPU side, and you will it will trigger a callback function, and you can do anything in this callback. Another way for you to do so is to register your game object into the simulation framework. And once your game object is registered, it can receive the collision response. And then you can do some gameplay logic according to the collision information. Maybe I can show you a little about the code. So you can see these are the codes, and here we have an act com. This is a 2D version, and we have everything also a 3D version. So if you can put this script on your game object, and you must make sure it has two functions that are returns an ABB and returns a velocity. Then you can implement your callback here. So this act 3D structure basically contains some information about the collision, like the collision normal, and whether its collision happens or not, and the velocity of the collider. So you can use this information to trigger some your game logics. So it's very easy. You only need to make this script attached to your game object and add some function to it. If you have multiple different game objects, I think you can make a new class to inherit this one and implement the logic. And let's have a look at the simulation, the code about the simulation. Maybe there are some internal functions you don't need to pay too much attention. And here is the interface, the API for you to use. Okay, this is to start the simulation. And once it starts, it will create some memory before the simulation. This prepare is to create GPU buffers, and this play frames is just to play the simulation step by step. You can play multiple steps at once. Only need to change this parameter, and we can pause the simulation. You can see that it only sets this variable to false, and in that simulation loop it will just do nothing. And we can also stop the simulation. This function will clear all the game objects and all the memory, including the memory in CPU and GPU. And basically this will clear everything. Okay, so this is often used to stop the simulation and shut down all the stuff. And you can also set some parameters. This spawn immediately is used to spawn particles. And this is auto spawn. It's only just change a variable to true or false. This one is for you to clear the game objects in the game. It will just clear the game objects, but it won't clear all the buffers on GPU side. So this is useful when you want to restart the simulation faster. And this function is for you to register your game object to the simulation. And if you did so, in each simulation, the framework will put your ABB of your game object to the GPU side and do some calculation between your game object and the particles. And once they are collide with each other, it will send the message back to CPU side, and you can use that information to do some game logic here. And this is also to register, but it won't check if your game object has been registered before. So I will recommend to use this one to make it more safer. This to unregister actor, and this is the response from the GPU. As the name suggests, it will get the feedback from GPU side and send the callback. Okay. Actually, nowadays there is a 2D version and 3D version. The 2D version currently have more features. Okay. So since basically I used to just want to create a 2D version, but finally I realized that the 3D are very similar because they follow nearly the same logic. The only difference is that in 3D we have 3 coordinates. Basically the logic, most of the logic are the same. Okay. So if you have more questions, you can go to have a look at the documentation. The documentation is in the docs. There are 2 readme for you to install this simulation framework and a PDF about more details. You can also send me an email for me to help you. Thank you.